Alright, so let's do a quick problem, and we may have a shorter session today, but that's okay. Since these are both the same, and one's about the x and one's about the y, we're going to pick this, and I'm going to show you, or try my best to show you give it a second. Past it. So I'll try my best to show you an approach towards this. Now, both of these, hang on, let me get my hand in the setup for doing this. Okay, both of these, you've got the possibility of doing this, or you got the possibility of doing this. Now, each one's a little bit different. Now, in the book, what he does is he generally will create a column and then has the dx and looks at the centroid and moves the thing to here, and he has the 1/12 base times height to the third. He breaks this into either a dx with a part in front of it or a dy. Now, that's not the way you really learn to approach things in Cal 2 or whatever. What you did in Cal 2 is you looked at this little square, and you have a dx and you have a dy, and you know those, so I'm going to remove those. And now, what your key is this. You either take this square and you run it from here to here in the first integral, or you run it from here to here in the first integral. Then once you do that, you do the other. One is moving up and down. So in other words, I'm saying you have this, and let's say we're going to do the x squared, just case in point. And then, oops, I'm sliding around. Then what you do is you either do a dx, a dy, or you do a dy and a dx. So let's stare at this a minute. Now, okay, if I run it up and down, I bump into, okay, let's break this into the components it is. I either have y is equal to x, 2, and a third component, or 2/3. Or I have, and I'm just writing it over here, not for any particular reason, y to the 3/2. I either have one of those or the other. Now let's stare at this for a minute, and before I decide which way I'm running it, let's look at what's in the middle. And I'm going to basically move these out to the side and say, I've got to come up with an integral in which, after the first execution of it, I would have something. Here's what I would have: either d something, d something. Then I'm going to have another integral. So in other words, I'm not going to address what goes here yet, or what goes here yet. But what I am going to address is that I can't do anything with this per se, except now need to have a dx with a bunch of junk that came out of that. So I don't know if I'm making sense, but so the key is which one do you do? Well, let's try both. Okay, and we'll maybe learn by trial and error. So let's do dx and dy, just for the sake of argument. And what does x go from? X goes from here. I'm going to just draw here, I'll do it this way. I'll move my block out of the way. Move it up here somewhere. And then I'll say my X is going from this point to this point. So my X is going to go from, okay, the first spot it's going to go to is going to be a function. The second one's going to be 1. Where does the X start from? Well, the X, you're either going to put in this one or that one. Well, that one doesn't have any. This one does. So you're going from y, oops, to the 3/2. Okay, and okay, I hope, I really hope. Oh, good. Okay. I'm going to use this to get myself through these because I don't. Oh, tip of the day. So what I usually, if I don't feel like paying a lot of extra money for something, I generally go with a package called, and I guess I'll at least show you where this came from, what it is. Tell you a little history. I have a history with this. It is a okay, so if you notice, okay, so in the search, somebody paid an ad here for the first thing. Then they paid, looks like Nissan got the second, a couple of places to find it, a few questions, and then there's an computer algebra system. Okay, this thing dates back a long, long time, and it is, if you notice, it's some of the first, and in my opinion, some of the most powerful that has been developed and used over the years. I use it because years ago there was a problem and the other methods did not work and this one did. So let's look at this. Let's say calculus, integrate. Now what it's saying what do you want to integrate? And do you want to do a definite integral? Let's try this. Okay, first of all, whoops. I'm going to use the keyboard. I'm integrating x squared. I'm integrating from, I don't want that there, y to the 3/2, and then to 1. That's kind of interesting. Okay, let's see what we get. Oh, hang on. Let's try this. Did I get rid of it? 1.5. Let me stare at that a minute. Oh, there's an extra parentheses I think they got. Up, shift enter. Okay, first of all, I don't like that that's on the next screen. Okay, so what this is saying, how do I make it bigger? I don't know that I can make it bigger. Okay, here, let's hit the shift and enter again. So what he's saying here with this 4.5 by 9.2, so he likes to get rid of things. So this is the integral. What I'm gonna do, I guess, can I just, with this, I don't know whether this will copy straight down. This should be interesting. I don't know what I'm going to get here. Control C, come back here, Control V. No, not really. Tell you what, we'll do it this way. When in doubt, I can't make it any bigger. I'll just copy it. 1/3 minus y to the 9/2 over 3. Now, here I have an integral that's dy. Okay. Now, what I'm doing here is I'm not running east-west here. I'm running north-south. So running north, I start at 0. I'm assuming that's 0. And then I'm moving, let's see, I'm trying to push the button with my pen on the pen. Trying to move this back a little bit. Now, what's my y at the top? Well, it's not that, it's this. And now you got a problem. Because what are you going to do here? So the issue is the x is left there. So you got an x left there. So how do you deal with that? You don't. So what we're going to do is we're going to do it this way. I'm going to swap. Let's see if I can use the magic of copying. This out of the way. Sweep through here. Slide it out of the way. Okay. I think... Okay, hang on. And move this. I don't need that anymore. Move this back a little bit. So now let's look at dy. I may have had this backwards. So in essence, let's start back at this dy. What does y run to? I already talked about that. Y runs from 0 to x to the 2/3. So if I go in, of course I'm doing each individually these all the way through. So x squared is just x squared. And so what you end up with from that first integral, or from the first integral, is x. Here, I'll even do it. Here, let me just even use this thing. Go back in. Whoops. Going to integrate. Now I'm not going to integrate anything but, x squared. X squared. I'm integrating with respect to y now. I'm integrating from 0, to x brought up to, okay, got to be, he does not like, for some reason, the 2/3, so I've got to do 0.666666, and what did I do wrong here? Oh. What did I type in there? Oh. Well. Yeah, we know what this is going to be. This looks to that to be a constant. So it becomes x squared, and then evaluating from y from 0 to x to the 2/3. So I can just put in x to the 2/3, 2/3, And then what happens is x squared times that becomes the addition of these. Let's see, x to 2 2/3. That'd be, think about this, 2 would be the same thing as 6/3 plus 2/3. It'd be 8/3. And that's going to be integrated from y is equal to 3/2 to 1 in dx. So I think I'm messing this up, which actually is a good reason to do the lecture this way. Okay. I think I had it correct the first time. So I may go back to his method and look again. Hang on. So in his methods, okay, he wants to do it with a vertical bar or a horizontal bar. Let's see. If we look, oh, he was doing the y here, and he was doing the y here as well. So what I want to do is I want to come back in. I'm going to come back in and do what he did here on ours, and then I'm going to try to patch it together. So what he's done is a d area here looks like this and a dy. Okay, so let's take a look at that and compare it to ours. I'm going to focus on this one to avoid that. Okay, so if you look at this one, he runs the bar from the left side to the right side. Let's do that on ours, if I can bring it back up. Whoop. So let's do that first. What I'll do is take what I've got here, move it out of the way, and then let's run our vertical bars first. I'm sorry, I meant to say horizontal bar. And if you compare what he has, or what he did, this is a dy, and that d area there is going to be the distance from here, or 1 minus that distance, and that distance is the x, and that x is the y and 3/2, and that's the dy. Now, if you stare at that for a second, you realize, okay, oh, I think I was doing, no, I was doing dy. Well, no, I was not. I was doing dx. I'll go back and look at the dx in a second. Okay, so this is his D area. And then what he does is put that in. Now, at this particular point, since you have a y, the only thing you can do legitimately is put the y squared. You can't really put the x squared. So if you want to do the x squared, you have to run your vertical bars this way from here to here, and that would be dx, and the d area of that vertical bar would be, the height would be that, or x to the 2/3, that's the height of the thing, times dx. So this can be put in here with x to the 2/3. And that would be the integral there. Now, the catch-22 is, if you look at each of these, okay, over here, these are two different terms. This is the I, y, and this is the I, x. Now let's go back and see from Cal 2 how you would have gotten these or a similar component. So the first part of this lecture, even though it's live, we'll sort of toss it in our own minds out. So if you look at this thing, you can go with your bars from left to right here, and you can find this because the y sits here, and you can represent this with a dy. The d area is represented as a dy. How could you have gotten that in a regular Cal 2? Well, let's look at our particular case. And instead of the gibberish I've got over here so far, I'm going to move it even further to the right. And then I'm going to say, how in Cal 2 would you have gotten this? Well, in this, you would have had a dy, and you'd had a dx, and you would have had a y squared, and you would have gone, okay, where would you have gone from? Where would the x have gone from? The x would have gone from right here to right there. So the from y to the 3/2 to a 1. So in essence, what's happening here in this one, okay, I can't get it, okay, hang on. In essence, what's happening on this first one, your little object in the first integral is going back and forth and touching up along this. So it's basically being sent back and forth, integrating from the left end to the right end. This is the little d area right here. The second one, the integral just goes from the bottom to the top. Okay, so this with this dx in here, I'll just put a box around it. This would have yielded you this component. Now if you look back at the book, oh, that's not the book. Up. Look back at the book. This is exactly what he did. He just came in here, so he circumvented in a way what you learned in Cal 2 and jumped that one step. And the next integral, he goes from 0 to the 200. And so in our case, it's not 200. Oh, in our case, it's 1. So you go from 0 to 1. Same thing over here, 0 to 1. Now, how would you have gotten this? because this has to come out of something that says something dy. Well, what are you integrating there? You're integrating x squared, which to y is just a constant and can be drawn out, but I'm not going to draw it out right yet, because this is this term. So what are my limits here? Now I'm looking at a bar that my bar first runs along the y. So in other words, the first integral, the first integral is running from the bottom to the top. So when it hits the top, what is it there? It is the top is from that equation. So the y would have gone to it would have gone from the bottom to the top, x to the 2/3. And in fact, this integral, after you perform it and put in the upper and lower integral, ends up with that. Now, if you want to avoid using this parallel axis theorem here, I would say make sure that if you're trying to find Ix, which the y will end up in there, make sure your bars run from left to right. If they run from left to right, you don't have to use solution type or case 2. In case 2, you've created a bar, you've found the I bar about it, you use the parallel axis theorem to get this, and then you took it and put it in there. So what he's forcing you to do is use the outer integral of dx. Up here, he's using the outer integral dy. There's no reason to work extra hard if you don't have to, so you can solve these either way. This is a direct image of Cal 2. This is a little bit different, and it uses the parallel axis theorem to swap the integral. In other words, down here, up here, you're effectively doing this. You're doing y squared, and you're doing a double integral, and on the outside is y, on the inside is x. Out here, or down here, you're doing it this way. You're doing the y squared, you're doing a dy, and then dx. It's doable, but it's not very fun. So, now, does the internal term out of here end up that way? If you got y squared, which you do, and then you take the integral of it, you get y third over 3, sorry. And in fact, that's what you get here. But this is a different method that essentially uses the parallel axis theorem. So up to you which one you want to do. Out here, I don't know. It's completely up to you. So I don't think I finished this problem. Let me finish it, and I guess I'll have I'll essentially have two answers here. So, okay, we already showed that this internal integral is what gave you that. So now let's go down and solve this one, which is the y squared 1 minus y to the 3/2 of dy evaluated from 0 to 1 gives me something. And this one, so this one will be my ixx. The iyy will be this one, 0 to 1. What did I end up with? X to the, and I was doing this over there and I stopped it because I wanted, anyway, it doesn't matter. So 2 plus 2/3, same thing as 6/3 plus 2/3 gives me 8/3 dx, which I did that a minute ago. And if you just want to go in and, oh, wait a minute. Okay. That is not what I'm looking for. Hang on. Oh, it's off the screen. That's why. So this time I've messed things up here. But let me go back. I'm integrating. I'm going to do the first one. Integrating x brought up to the 8/3. I'm integrating that from, I'm integrating x from 0 to 1. And I already have my pressure. I have to hold the shift key down and hit enter. 3/11. Now let's integrate this one. Now they won't be the same. Well, now wait. No, they won't be in this case. Integration here, I'll just use the past part that I've written here. I'm going to go integrating with respect to y, and I end up with y squared times 1 minus y brought up to the 3/2. And I believe I have all my things good. Shift enter 1/9. Now somehow, okay, let's look at the problem number. F1 or F3. Now, I don't think, here, let's see. F1 or F3. Okay, the F's came before F10 one. Wait. Okay. So again, he has the thing written here. And again, let's see. The first one is 0.11. I think that's what you're going to get if you enter. Okay, I got 1/9 and 3/11. 1/9 and 3/11. Ooh, I may have messed up the second one. He got 0.22. Oops. What did I do? Why the 3/2? I goofed that one somehow. So I goofed this bottom one. Oh, wait. Okay. What? I think we've got a problem here because did I do the wrong one? I did this one, but then I did for this other one, I did that. He did not do that for this one. Maybe I misinterpreted in the sense that I thought they were the same problem. Okay, now I've lost track of where they are. To me, I see these as being the same problem. Y to the third, am I seeing this the right way? Y to the third equals to x squared. That's what I'm seeing. So I'm not so sure I believe that. About the x-axis and about the y-axis. So I'm not so sure I believe what he did in the back of that. Oops. Here, I'll get rid of some of these. Okay. Well, I think we got a problem here. So I'd believe that one, but he's saying the same object. Yeah, I'm not so sure I believe that. How can you have the same integral? You're representing it differently or similarly and have two different answers. Logically, that doesn't make sense. So, by nature, if I'm trying to decipher what he's saying, then this is the integral of the dx. Does it go from 0 to y 3/2? Because the function looked like this. And y isn't 3/2. X, okay, x goes from I may go back and try to do this, try to decipher what he's trying to come up with there, because he's only doing this And that doesn't make any sense. So we may pick this back up on Monday and do this in the class. Try to figure out what in the world is he actually trying to do with respect to. So I may bring my tablet in and try to figure out how I can connect it. So because he's claiming x will go from 0 to y to the 3/2. So, okay, x going from 0 to the y 3/2. That's not what's happening here. So the function doesn't change as you move across the page. In other words, what I mean by that is this. Okay. All right, hang on. This is fine, but both of these functions are the same. Let me look again. Y to the third, y to the third, x squared, x squared. So I don't believe what his solution there at all. This one, okay. So I think what we'll do is just pick this up on Monday and hammer this thing out. This is very annoying, but we'll hammer out this problem and maybe pick up another one, and then we'll move on from here. And we might do this with these two as well. So it's a similar thing here. I see a repeated equation here. We're going to do this one as well. So we'll do this one on Monday as well. And from there, we'll go on from here. So I'm going to call it quits here, and we'll pick it back up again on Monday. I'll try to bring this in and figure out how to cast it to the screen.